Hey everyone, and welcome. Today, we're going to tackle the pretty complex world of digital storage. If you're a creator, a power user, or, just anyone with a data collection that's getting a little out of hand, you know that building a solid, reliable system is absolutely key. So we're going to cut through all the marketing noise and lay out a real blueprint for building the perfect storage system for your needs.
Right? I mean, just look at this. The market is just a sea of acronyms, and trying to pick the right tech can feel impossible. Should you go for raw speed or maybe massive capacity? What about long-term safety? The real answer is, well, you kind of need all of them, but you need them in the right places. And that's exactly what we're going to map out today.
So here's the game plan. First, we're going to introduce this really powerful idea called the storage pyramid. Then, we'll break down each level or tier from the super fast hot storage all the way down to the long-term archival guardians. And then, we'll put it all together into a practical plan you can actually use. Okay, let's get into the core concept for this entire explainer, the modern storage pyramid. See, this isn't about just buying one type of drive and calling it a day. It's about building a smart, layered ecosystem where every single piece of technology gets to play to its own unique strengths. The idea here is actually pretty simple. Think about it like this. At the very top of the pyramid, you've got your hot data. This is the stuff you need right now, like your operating system or the project you're actively editing. This tier is small, it's incredibly fast, and yeah, it's expensive per gigabyte. But as you move down the pyramid through the warm and cold tiers to the giant archival base, the storage gets way bigger, a lot slower, and dramatically cheaper. This model is the absolute key to balancing performance and cost. All right, let's start at the very top, the peak of the pyramid, the hot tier. This is all about one thing: speed. We're talking about eliminating bottlenecks and getting the absolute maximum performance for your most important work. And in today's world, that really means one thing: NVMe.
And here's the secret to why NVMe is so unbelievably fast. You see, older standards like SATA were built for old-school spinning hard drives. They have a ton of baggage. NVMe, on the other hand, was built from day one just for flash memory. It gets to skip all the slow, old controllers and talk directly to your computer's brain, the CPU, using the super-fast PCIe bus. It's like having a direct private highway instead of taking slow city streets.
Now, to really appreciate just how fast that highway is, you have to see the traffic jam it replaced. This number, around 600 megabytes per second, is the hard speed limit of the SATA 3 interface. It doesn't matter how fast the chips on your SSD are, if it's a SATA drive, it can never, ever go faster than this. It's a fundamental bottleneck.
And wow, this chart just says it all, doesn't it? Going from SATA to a modern PCIe 4.0 NVMe drive isn't just a small bump. It is a massive, monumental leap in performance. We're talking well over 10 times the speed. And with PCIe 5.0 becoming more common, that gap just gets even more insane.
So, speed is awesome. We love speed. But what about safety? What about reliability? This question right here gets to the single biggest and most frequently overlooked difference between a consumer drive you'd buy off the shelf and a proper enterprise-grade one. Okay, this is so important. A lot of consumer SSDs use a tiny bit of super-fast DRAM as a cache. But that cache is volatile, meaning if the power cuts out, anything in it is just gone. Poof. And that could be the last few seconds of your work, or worse, it could lead to silent data corruption, where the file looks fine but is actually broken. Enterprise drives, though, have something called power loss protection, or PLP. They have these tiny little capacitors on board that, when the power fails, give the drive just enough juice to safely write everything from that cache to the permanent flash storage. For any critical work, this feature is an absolute must-have. All right, let's move down a level to the middle of our pyramid. This is where most of our stuff actually lives. Our photo libraries, project archives, backups, you name it. These are the high-capacity workhorses of our system, where cost per terabyte really becomes the most important factor. Now, if you are buying a hard drive today, this is probably the most important thing you need to know. CMR is the traditional, reliable tech we've used for years. But to squeeze in more capacity, some drives use SMR, which overlaps the data tracks, kind of like shingles on a roof. Here's the problem. If you need to change just one little piece of data on an SMR drive, it has to pick up and rewrite a huge chunk of data around it. This makes performance absolutely plummet, sometimes for minutes or even hours. In a NAS, especially during a stressful array rebuild, SMR drives can be a complete disaster. you really want to look for CMR.
And beyond just being at CMR, drives built for a NAS or for enterprise use have some other key benefits. They're rated to run 24/7, they have better failure ratings and longer warranties. But that last feature, highlighted here, is the really crucial one: rotational vibration sensors. See, when you pack a bunch of spinning drives together in a box, they vibrate a lot, and those vibrations can actually throw off the sensitive drive heads, killing performance. RV sensors detect that vibration and compensate for it, keeping everything running nice and smooth.
And now we've reached the foundation of our pyramid, the archival tier. This isn't for data you need every week or even every year. This is for the truly irreplaceable stuff, the final, offline, break glass in case of everything copy that protects you from ransomware, theft, fire, you name it. This is about your legacy. So you've probably heard of disk rot, right? Where old CDs and Blu-rays just stop working. That's because they use an organic dye layer that degrades over time. M-DISC is different. As this quote says, it uses a stable, rock-like, inorganic layer. The laser isn't just changing the color of a dye, it is literally physically etching your data into this material that's rated to last for 1,000 years. So, what's the catch for that incredible 1,000-year lifespan? Well, it's cost. As you can see, the M-DISC media itself is pretty pricey per terabyte. Now, on the other end of the archival spectrum is LTO tape, which is the enterprise standard. It has a shorter lifespan, though 30 years is still fantastic, but the media cost is just unbelievably low. We're talking around $5 a terabyte.
Ah, but here's the twist, and it is a big one. While the M-DISC media is expensive, the drive you need to write it is pretty cheap, about $100. For LTO tape, it's the complete opposite. The tapes are dirt cheap, but the drive you need to read and write them costs thousands of dollars. And that, right there, is the ultimate archival dilemma for prosumers.
Okay, we have explored every single level of the pyramid, from the fastest flash to the longest-lasting archive. Now it's time for the final section. Let's bring it all together. How do we actually use this knowledge to build a system that is balanced, affordable, and safe? This is the blueprint. And here it is, the whole pyramid in one table. This really gives us some clear answers. Look at our warm tier, the main NAS array. If your number one goal is the lowest cost per terabyte, shucking external hard drives is the winner. For your hot tier, like your PC's boot drive, a regular consumer NVMe is perfect for maximum read speeds. But if you're running something like ZFS and need a super fast write cache, that enterprise NVMe drive with power loss protection is really the only safe way to go. And then for that final archival tier, LTO tape gives you an unbeatable media cost and, crucially, creates a true air-gapped backup, meaning it's physically disconnected and totally safe from online threats. As you can see, every technology has its perfect place. You know, in the end, thinking about storage as just a single drive you buy is the old way of doing things. The modern, resilient way is to build a pyramid, a whole system where every tier is doing its job, protecting and supporting the others. This isn't just about storing files anymore. It's about preserving your digital life, your work, your memories. So the final question I'll leave you with is your pyramid built to last?